Hello, my name is Hisham Al Ismailat, and today's date is August 25. This video is my week 15 structure elucidation for sample AB, which is C11H14O. So I begin by calculating the degree of unsaturation utilizing the formula half multiplied parentheses 2 plus 2C minus H minus X plus N. The C is the carbon, which is 11. H is the hydrogen, 14. We don't have any halogens and we don't have any nitrogen. So we end up with 5 degree of unsaturation. My IR table has two columns, a frequency and functional groups. And here's exactly how I filled each entry. I first scan the 3100 to 3000 region. As we see, a band near 3030 tells us there are sp2 C single bond H from an aromatic ring. So I typed 3030 in the frequency column and wrote aromatic C single bond H stretch in the functional group. Over here, we have uh, weak bonds, as we see, just below 2800, which is a characteristic of the CHO combination bands. So I recorded 2760 and labeled it as aldehyde CH single bond. Uh, and I always check the 1850 to 1600 for carbonyl. And as we see, there's a very strong band at 1710, which fits an aryl conjugated aldehyde. I entered 1710 and wrote CO double bond stretch of aldehyde. Over here, we have 1009. It's aromatic CC double bond stretches, which supports the benzene ring. Over here, it's about 1048. It is a cell CO. It's a fingerprint it's in the fingerprint region. And over here is my 13C table, which has chemical shift and the type of bonding environment. And I will explain how I got each value from the graph. At 192 ppm, we can see carbonyl aldehyde over here, type 11. At 140 ppm, it's aromatic C type I9. For that one, I use the 140 region for lispo aromatic carbons. 128 is aromatic CH type 6, which is typical for protonated aromatic carbons. And over here, we have 38 ppm. It's CH2 type 4 and 24 ppm over here. It's CH2 type 3. Those are two downfield aliphatic carbons fit a benzylic CH2, which is from 35 to 40, and the middle CH2 20 to 30 of a straight chain. And over here, we have the 22. It is methyl type 2. I assigned this as an aromatic methyl, ARCH3. And lastly, we have the terminal CH3 of the straight chain. And this is my 1H table, which has chemical shift, integration, multiplicity, and interpretation. And this is the graph of it. At point 95, integration is 3H, multiplicity is triplet, interpretation is two hydrogens, which means it couples to two equivalent neighbors. By the way, this is the terminal CH3 of an N-propyl group. Over here, we have the 1.70. Integration is 2H, multiplicity is sextet, and interpretation is 5 hydrogen, meaning it sees 5 neighbors, 2 on one side and 3 on the other. This identifies the middle CH2 of the propyl chain. Over here, we have the 2.20. Integration is 3, multiplicity is singlet, interpretation is 0 hydrogen, so no adjacent protons. So I assign this one as an aromatic methyl, which is ArCH3. 240, which is over here. Uh, Integration is 2, is um, multiplicity is triplet, interpretation is 2 hydrogen. This is the benzylic CH2 directly attached to the aromatic ring, coupling to the middle CH2. Over here we have 740. Integration is 1H, multiplicity is singlet, and interpretation is 2 hydrogen. And we have 770. Integration is 1H, multiplicity doublet, and interpretation is 1 hydrogen, and another aromatic proton orthocoupled to one neighbor. And lastly, over here at the end, the integration is 1, multiplicity is singlet, interpretation 0 hydrogen. This is the aldehyde proton. So lastly, we go to the structure. This is the structure from the DU and IR tables. We know we have an aromatic aldehyde. The 13C table shows an aldehyde CO double bond, 192 ppm, aromatic carbons, 140, 128, propyl carbons, 38, 24, 14, and an aromatic methyl, 22. The 1H table shows CHO at 9.80, 3 aromatic protons total, a propyl T sextet, T sextet, T button, and an ArCH3 singlet, which all evidence by a benz aldehyde bearing one methyl and one N-propyl group on the ring in a 1,3,4 tri-substitution pattern. That is for methyl 3-propyl benzaldehyde. Thank you so much for watching, and have a great day.